the last little trick that we talked about a little bit there is, what if I said c.add new integer 5 inside here. Let's add a dog named 5. This would work. This would be totally fine. Everything would run just fine because I was clever enough to use the toString inside of here. But if I said instead that I was going to come down here and say I want to do string, sorry, let's put this here, string s is equal to string of o s dot length. I want to see how many characters are in each one of these strings. I get the exception. Class cast exception. Integer cannot be cast to string. Okay, it's, again, a little bit arbitrary because I could just do a toString on this and I could still get the length of that and it would show me the length of 1 because it would be the character 5. But that's not the point. The point being is I don't know what's inside this collection. I have no way of guaranteeing what's inside this collection. And so the way I work around that is through generics. And what we saw inside of there, when we hit control space here, you can see it says E inside of here. This is saying it's capable of being generics, but it doesn't require you to. If you use Eclipse will automatically pop up the generic stuff for you, and it'll actually say, hey, you should fill this in. For some reason in NetBeans they chose to say, you can do it or not. So what I can do instead is say collection of strings. And then all of a sudden, it says to me, I can't put this inside of here. I can only put a string inside of here. I can't put an integer. I cannot put, let's say, a new linked list. I can't put that inside of here. Let's see, it's going to give me an error. Linked list cannot be converted to string. I can't make it into a string that way. So it guarantees me that this is unique to the stuff I want to store. So I can just take that out and fix that there. Now, notice here, it doesn't put the same thing on linked list. To be absolutely perfectly correct, I should also put string over here. And that would make my life a little bit easier over here. It now is actually getting to a little bit of some extra coding inside of here. You can see I'm starting to get some yellow pop-ups here. Can use functional operation. What that means is I can make this string s inside of here and get rid of that line of code. Up here, you can see it says suspicious call to Java collection.remove. Expected type string, actual type object. So it knows it's a generic out there. It doesn't say it's going to fail. It's just saying to you, by the way, this is a string inside of here. But it doesn't know it because I didn't make the iterator a string. The iterator as well can be cast to a type of string. We can say this is a string iterator. Because we defined the collection of type string, the iterator can be type string. And so I don't need to do the toString anymore. I can just do O dot starts with string and C dot remove O, and then all of a sudden, I don't need to do toString down here anymore either, because you see it gives me a warning, redundant string dot toString. I just say O down there. So it's not going to functionally make my code do anything different. It's not going to change the way my code performs. It's going to perform just the same speed as it would otherwise, because all that stuff will be optimized out at compile time. What it does is it protects me against myself and other coders who might come in and not realize what I intended to be stored inside of here. This is supposed to be a collection of strings, or better yet, people or dogs or whatever, because you can see I have Tony and Nikki and Jesper. Nikki and Jesper are my dogs. Tony is people. So I don't necessarily want to represent everything as strings, because a string can be any text. It's not supposed to be just any text. It's supposed to be specific things. And that's the next iteration that we're going to get to, and what you're supposed to be doing in your project. Now, if you've built your project the way I've suggested you build your project, then you should be darn tootin' very near being finished, being ready to go with that. Shouldn't have much to go clean up and finish up, except for just making sure we're using all this stuff clearly and appropriately. So we're going to take a quick look at that here in a second. But certainly, my goal of this class is not just that, yeah, I used a collection one time because I copied over what the instructor did in a demo one time. I want you to understand it. I want you to see it. I want you to understand these behaviors. I want you to play with these behaviors and feel confident within it. So again, let me just run this one more time. You can see everything comes out. It's real nice and clean, and it moves very nicely inside of my solution there. All right, so play with this a little bit. Make sure you understand how I can use generics inside of there. You can get into some compiler issues a little bit. You have to be careful. But if you understand the syntax of this, you have the collection, and then inside these angle brackets here, the greater than less than sign, I need the type of the object I want to store. Ideally, then, I create my linked list, my array list, whatever you're going to use. Again, that including the type of the object I want to store. I probably won't use an iterator directly, but you'd be using the for loop inside of here, and then for that collection, I can loop of the type of the object that is stored up here. And then it should all work. It should all be nice and clean, and all the types should align, and all your code should align with minimal fuss, and the compiler as your friend in this case, instead of beating you up for making mistakes.